You know that feeling when you look at like a piece of ultra-modern minimalist architecture?
Oh, yeah, definitely.
Like one of those really high-end kitchens. There are no visible seams, no handles on the cabinets. Everything is just this continuous, smooth, monolithic surface.
Right. It looks incredibly elegant.
Exactly. It looks like it belongs on the cover of some architectural magazine.
And yet it is completely impenetrable.
Yeah.
It's this unified whole where nothing disrupts the visual aesthetic, but you are just left standing there in the middle of this beautiful room, totally starving, fumbling around trying to figure out how to simply open the refrigerator.
Because there's literally nothing to grab onto.
Exactly. There's just no point of entry for a normal person.
It is the ultimate clash between aesthetic elegance and, well, practical utility. When the design prioritizes looking clever over being usable by an actual human being in the real world.
Which is a huge problem.
Right, and that tension between making something look incredibly slick and compressed versus making it genuinely accessible is exactly what we're exploring today. Welcome to this custom-tailored deep dive, where we are looking at a very universal dilemma that is, surprisingly, hiding inside a highly technical blog post.
It really is a tug-of-war we all face, whether we're conscious of it or not.
For sure.
We are always deciding who we're communicating for, you know? Are we trying to prove our expertise, or are we, like, actually trying to be understood?
Okay, let's unpack this. Our source today is a post from July 11th, 2026. It's written by a developer named Ang, and it's titled Notes-on-Haskell-Programming Part 184, The Case of Balancing Readability and Conciseness in Refactoring.
Quite a mouthful of a title, honestly.
Yeah, it really is. But even if you have never written a line of code in your life, stick with us, because the core tension Ang is wrestling with here applies to absolutely everything you do.
It really does.
It's that dilemma of deciding whether to use highly concise insider shorthand or to just spell things out explicitly. It's the exact same choice you face when you're deciding whether to use, like, a dense cluster of acronyms in a quick work email.
Or when a lawyer debates drafting a super dense legal clause versus just writing it in plain, understandable English.
Exactly. Ang happens to be writing about software engineering, but the underlying crisis of conscience is entirely about human communication.
Yeah, we're looking at a scenario where a professional has to choose between what their industry considers quote-unquote perfect and what a normal human brain can actually tolerate.
So I was looking at the actual code snippet Ang shared for this post. It's for a function called withTemplate.
Right, the core example.
Yeah, and even to a complete layman, the before and after versions of this code look like two completely different languages. So break down what actually happened here. What was Ang starting with?
Well, we need to understand the mechanism of the original code first. Ang was working in a programming language called Haskell. And the before version of this function is what programmers would call verbose.
Meaning it's pretty long-winded.
Exactly. It takes up a lot of vertical space on the screen. It uses this specific mechanism called a do block.
A do block. Okay.
Yeah, and you can think of a do block as a very rigid, stubborn checklist. It literally forces the programmer to explicitly write out every single action on a new line.
Oh, God.
So it's like step 1, do this. Step 2, evaluate step 1. Step 3, make a decision based on step 2.
Okay, so it's really forcing a narrative structure. It's spelling out the chronological logic step by step for anyone reading it.
Yes, precisely. And within that rigid checklist, Ang had to deal with something called an either return type.
Which is what, exactly?
In Haskell, the either type is basically a way of handling unpredictability. Imagine a fork in a train track.
Okay, I'm picturing it.
The data flowing through the program is the train. When it hits this operation, it's either going to successfully go down the track labeled, right, meaning the operation worked, or it's going to fail and get diverted down the track labeled left, which is the error track.
Oh, that makes sense. So in this verbose step-by-step checklist, the programmer actually has to build a manual switch operator.
Exactly.
They have to write code that says, like, look down the track. If the train is on the success track, do action A. If the train is on the error track, do action B.
That is the perfect way to visualize it. And that manual switch operator is called pattern matching.
Pattern matching, okay.
The old code had these dedicated lines of text solely existing to check which track the train was on and then route it accordingly.
Which sounds a bit exhausting.
It is. It's tedious to write. It takes up a lot of room. And for an experienced developer, writing out those manual switch operators over and over again just feels clunky.
Right, it feels like you're doing busy work.
Which totally explains the temptation to clean it up.
Huh.
Because Ang then shows us the aftercode, the refactored version.
And this is where it gets crazy, because Ang takes all of those distinct lines, the checklist, the manual switch operator, and compresses it all down into a single, highly dense horizontal line of code.
Yep, all in one line.
It looks way less like instructions and more like, I don't know, a complex calculus equation packed with abstract symbols. It's just with template, f equals get template, then a bind operator, and then either pure dot left f.
It's very dense.
How does that single line even manage the train tracks without the manual switch?
Well, it does it by using incredibly powerful built-in tools that route the logic automatically. Instead of writing out the manual check, Aang used something called a bind operator, which, as you noted, looks like two greater than signs and an equals sign.
Right.
Conceptually, imagine you replace those open train tracks with a closed, pressurized pipe system.
Okay.
The bind operator is essentially a smart automatic valve. It takes the water, which is the data from one pipe, and automatically pushes it to the next step.
Oh.
But crucially, if it detects a leak or an error, it instantly diverts the flow to the error handling process without you having to write a manual line-by-line check for it.
So it's completely automated. You just plug the pipes together with this smart valve, and it handles all the routing internally.
That's the magic of it, yeah.
Yeah.
Aang combined that smart valve with a built-in function called either, which automatically knows how to handle the two different outcomes.
Huh.
By plugging these advanced concepts together, Aang removed all the structural boilerplate text. The narrative waypoints are just gone.
Right, the training wheels are off.
Exactly. In the Haskell community, this heavily compressed, symbol-heavy way of chaining functions directly together without naming the intermediate steps is called point freestyle.
Great freestyle. Okay.
And Aang readily admits in the post that this single-line version is the idiomatic Haskell approach. It is the technically correct, standard way an absolute master of the language would write this logic.
See, here's where it gets really interesting to me, because the difference between those two approaches brings to mind such a perfect real-world analogy.
Oh, let's hear it.
So the the verbose multi-line checklist is exactly like giving someone driving directions to a restaurant. You look at them and say, drive 2 blocks down Main Street, turn left at the gas station, go over the bridge, and then stop at the Red House.
That's right. Very explicit.
It takes a little while to say. It takes up a lot of breath. But literally any human being, regardless of their navigation skills, can follow it step by step, landmark by landmark.
Because it provides context at every turn.
Mhm.
You are never lost because you always know what the last landmark was and, well, what the next one should be.
Right. But the new code, this sleek, quote-unquote, idiomatic single-line code that is like bypassing the driving directions entirely and just handing someone a slip of paper with raw GPS coordinates.
Oh, that's good.
Like 40.7128 north, 74.0060 west. It is completely precise. It's vastly shorter. There is no wasted breath whatsoever.
Yeah, highly efficient.
And for a computer or like a GPS satellite, it is a vastly superior, perfectly optimized way to receive information. But if you hand a human being raw coordinates, they're just going to stare at you blankly.
Totally blankly.
You've removed the human narrative entirely in favor of pure, concentrated data manipulation.
And that tension is exactly why Aang is not popping champagne over this refactor. You would think that achieving the idiomatic, expert-approved, single-line solution would be a real moment of triumph.
Right, like a high-five moment.
Exactly. But Aang seems deeply conflicted about it.
Yeah, because Aang explicitly states in the post that this new hyper-compressed code is, quote, mentally taxing for other to read at a glance.
Yeah, that's a huge admission.
Aang points out that even though it's shorter, the reader has to stop and actively decode the smart valve and the built-in routing functions. The narrative just doesn't guide you anymore.
It really doesn't.
But, okay, let's unpack this a bit more. I have to push back on Aang's premise here for a minute.
For it.
So what does this all mean? If the bind operator and the either function are the standard idiomatic Haskell approach, aren't they just the basic tools of the trade?
I mean, arguably, yes.
Like if you hire a professional plumber, you absolutely expect them to know what a base and wrench is. If they don't, they're a bad plumber.
Fair point.
So if someone is writing Haskell professionally, shouldn't we expect them to instantly recognize a bind operator rather than catering to a less experienced reader by keeping things artificially dumbed down and verbose?
You'd think so, right?
Yeah. Shouldn't developers just learn their tools?
Well, it's true. You expect a professional to know what a base and wrench is. But imagine if that plumber had to use that base and wrench while balancing on a tightrope in the dark while a stopwatch is counting down from 60 seconds.
Oh, man. Okay, that's a stressful image.
Right. It's no longer just about whether they know the tool. It's about how much mental energy it takes to execute the task in a highly complex environment.
That makes a lot of sense.
What's fascinating here is that Ang's hesitation isn't actually about coddling beginners. It's entirely about a psychological concept called cognitive load.
Cognitive load. So it's not the knowledge of the tool itself, it's the environment in which the tool is being used. Cognitive load meaning like how much active mental RAM your brain has to dedicate just to process the incoming information.
Interestingly. Precisely. Because when a developer is reading through thousands of lines of code a day, they are rarely stopping to admire the ingenuity of a single line.
Right, they're just trying to get through it.
Exactly. They're scanning for meaning, trying to trace the flow of data to understand a massive interconnected system. So even an expert Haskell programmer, someone who knows exactly what the bind operator does, has to spend a fraction of a second longer parsing that highly dense, point-free line of code.
A fraction of a second adds up.
It does. They have to hold the abstract definitions of those smart valves in their working memory simultaneously just to decipher the pipeline.
Because it doesn't say turn left at the gas station. It just gives you the coordinates, so you have to mentally render the map yourself.
You had to do the translation in real time. And Ang specifically praises the old, multi-line, verbose code for bypassing this exact problem.
Oh, really?
Yeah, Ang writes that in the old code it is, quote, explicitly obvious how result, especially error, is handled. The logic is physically mapped out visually on the screen.
So you don't have to hold it all in your head.
Right. The structure of the text itself does the heavy lifting, offloading the mental work from the human brain onto the page.
So what does this all mean for the rest of us? It honestly makes me think of business jargon.
Oh, absolutely.
Like if I write an email to my team and I say, we need to synergize our deliverables to maximize the Q3 KPIs.
Ugh, the worst.
Right. Technically, an expert business person knows exactly what those words mean. The tools are understood, but it feels exhausting to read. It requires a translation step in your brain.
It really does.
Whereas if I just write, we need to work together to hit our sales numbers so we can finish the project, you don't have to decode anything. The meaning just enters your brain smoothly without any friction.
And that friction is the cognitive tax.
Yeah.
Ang is making a really profound argument here that structural elegance, making something look sleek, minimal, and sophisticated on the page often actively fights against, at a glance, readability.
Wow.
The goal of professional communication isn't to prove how well you have mastered the obscure vocabulary of your field. The goal is to make the meaning so unmistakable that the reader's brain doesn't have to work to find it.
Okay, that makes total sense when we're just talking about reading a document or scanning a code base. But as I was reading Ang's post, I realized that reading is really only half the battle.
Oh, definitely.
Because eventually things break. And this brings us to a fascinating point Ang makes about physical space. This is honestly the most practical argument for keeping the ugly old verbose code.
Yeah, we're transitioning now from the philosophy of reading code to the harsh reality of fixing it. When software breaks, you have to go in and find the bug. And Ang points out that the original verbose code is significantly more debugger-friendly.
Because of that physical space. When you have a do block, that rigid checklist with multiple distinct lines, you have actual room to maneuver.
You really do.
Ang writes that you can easily insert a trace or log statement between the lines if we need to debug the code.
Let's visualize how crucial that is. When a program is crashing, a developer needs to isolate the problem. Because the old code is broken into distinct steps, the developer can literally insert a pause button between step 1 and step 2.
Ah, that's so useful.
They can tell the program, hey, run the first line, then stop. Print out exactly what the data looks like right now so I can see it. Okay, now run the manual switch operator and pause again.
Right.
You can basically observe the state of the machine at every single turn in the road.
Which is physically impossible with the new, sleek code.
It is entirely impossible. The new code is a single, continuous, pressurized pipe. Once you push the data into that line, it flows through the whole smart valve pipeline without stopping.
Wow.
There are no intermediate steps. There is no physical space between the operations to insert a pause button or hook up a diagnostic tool.
Oh, this is exactly like the evolution of the technology we carry around versus the technology in our garages.
Oh, how so?
Well, the new concise one-line code is like a modern, ultra-sleek smartphone. It is a total marvel of engineering. Everything is soldered together, glued into one incredibly thin, beautifully sealed block.
Right.
It's hyper efficient. But if the battery suddenly dies or the screen starts flickering, you can't just pop the back off and fix it. You literally can't get between the microscopic components.
Yeah, it is a complete black box. You just hand it over to a genius bar and hope for the best, because the internal routing is completely inaccessible to you.
Exactly. Whereas the old verbose code is like a classic car engine sitting under a massive open hood. The parts are huge. They're clearly separated.
All right, you can see everything.
Yeah, there's actual physical space between the carburetor and the alternator. If the engine is misfiring, you don't have to guess. You can easily attach your diagnostic clips exactly to the specific valve you need to check.
That's a great comparison.
It might be clunky, it might look messy, and it definitely takes up more room, but when it breaks, a human being can actually get their hands in there and figure out why.
If we connect this to the bigger picture, code, much like a legal contract or a company's operational guidelines, is not a static piece of art hanging in a museum.
No, not at all.
It is a living, breathing document. It requires constant maintenance, updating, and fixing as circumstances change.
Definitely.
Eng's post beautifully illustrates a trap that creators in every field fall into. We optimize for the writer's keystrokes. We optimize to make the text look elegant on the day it is written.
Yeah, to feel clever.
Exactly. And
Yeah.
in doing so, we severely penalize the future maintainer who has to deal with the fallout.
And the brutal reality is that future maintainer is very often you. It's you, 6 months from now, at 2 a.m. on a Sunday, desperately trying to figure out why the entire system just crashed and is actively costing the company money.
And just consider the psychological state of that maintainer at 2 a.m. Under immense pressure, your cognitive capacity is practically zero.
Oh, absolutely zero.
You do not want a clever puzzle. You do not want an elegant, point-free chain of abstract logic that requires you to mentally decode smart valves and pipe routing.
No.
You want the classic car engine. You want steps 1, 2, and 3 laid out so explicitly, so obviously, that your exhausted, stressed mind can trace the error, insert a log statement, find the bug, and just go back to sleep.
So true.
Eng's hesitation to fully embrace the idiomatic shorthand is a hard-won recognition of this exact reality.
It totally reframes the whole idea of what makes a professional truly clever. Being clever isn't about using the most advanced jargon to pack your ideas into the smallest possible space just to prove you can.
Not at all.
True cleverness is having the empathy, and really the foresight, to build something that another human being can easily understand and fix when things inevitably go wrong.
It is the realization that clarity is the ultimate form of elegance. The highly compressed, idiomatic approach might perfectly satisfy the mathematical rules of the language, but it completely fails the messy reality of human collaboration and maintenance.
So to bring the lessons from Angst Part 184 directly back to you, listening to this right now, the next time you are sitting down to communicate something complex, whether you are actually refactoring a Haskell codebase, or you're drafting a crucial operational memo to your team, or even just putting together a strategic presentation for a client, you have to pause.
You really do.
You have to ask yourself a fundamental question. Am I writing this to look clever? Or am I writing this so the next person can easily understand and, if necessary, debug my logic?
That's the real test.
Are you building a beautiful, impenetrable, sealed smartphone?
Yeah.
Or are you building a classic engine with enough space for someone to actually get their hands dirty and fix it?
It's a vital check on our own egos. Really, it requires taking a conscious moment to prioritize the reader's experience and the future maintainer's sanity over the writer's immediate satisfaction.
Absolutely. And looking at this whole trajectory, this constant push in tech and business toward hyper-efficiency and minimal jargon, it leaves me with one final kind of wild thought.
Oh, what's that?
Well, if our programming languages and even our own professional shorthand are constantly evolving to allow for these incredibly dense, highly compressed formats like Haskell's point-free style,
Right.
formats which we just established, human brains actively struggle to read and debug, will we eventually reach a tipping point? Will we get to a place where our own idiomatic shorthand becomes so densely compressed that we have to rely entirely on AI just to translate our own work back into plain, verbose, classic car language, just so we can figure out what we actually built?
Wow. That raises a rather profound question about the future of how we interface with our own creations. If we obsessively write only for the machine's efficiency, we might soon find that we need a machine just to read it back to us.
It's something to mull over the next time you find yourself tempted to be just a little too clever. Until next time.